Good morning. Today we're looking at Chapter 5b, using data transformation to linearize a scatter plot. A student has asked me to provide a video walkthrough for how to complete the question up there. This scatter plot opposite was constructed from the table below. Got the data there. 0, 1, 2, 3, 4, 16, 15, 12, 7, 0. From the scatter plot, it is clear that the association between y and x is non-linear. So we are required to linearize the scatter plot by applying an x squared transformation and fit a least squares line to the transformed data. So as you can see behind me, I have my data already in my CAS calculator. List 1 is my x values, list 2 is my y values. Now, what I'm going to do is, if you see behind me, there's the little row there called Calc. If you click on the bottom of that for list 3, and you type in there, so it says there Cal, and if we type list 1 squared, like so, and we hit enter, it will now fill in all the values at the top there with the required or the appropriate numbers. Now, that is part of doing an x squared transformation. Now, what we have to do now is make a scatter plot, not using list 1 and list 2, but list 3 and list 2. So instead of using list 1 as our x values, we're going to use list 3 as our x values. So on our CAS scatter, we're going to do list 3. And we're going to draw our scatter plot. And there we have it. We have that there. Just going to scoot that over for you. All right. So as you can see now, dots are in a different place, a little bit cleaner. Now, from this, we are required to give its equation. Now, what you have to remember is that this might be a linear line, but where did I get my x values from? I got them from an x squared. So, when we do our linear regression analysis on it, using list 3 and list 2, as our formulas, as our x list and y list, and we hit OK, we are presented with what we've got there, a plus bx. So it says a is 16, b is minus 1, r is minus 1 as well, and r squared is 1. That means what we have is a perfect negative linear association. All right, remember, R is your Pearson value, your correlation coefficient. Minus 1 means it's perfect. It's a perfect negative. And once you've applied the transformation, it becomes a linear relationship. Now, where that comes in, and I'll answer your question in a moment, Athava.
Yep.
Where this comes in and becomes important is when you're required to give the actual equation. When you're required to give the actual equation, you have to remember what transformation you actually did to it. All right, so if I move this back over to where I got it from, and I bring up my whiteboard. So I have my whiteboard now. So based on the data that I've got here, A is 16 and B is minus 1. That would mean that if I was to write the linear regression for this, it would be y equals 16 minus 1x. So no need for that. But remember, what did I actually do to my x originally? I had to square it. Alright? So that means I replace whatever this x is with the transformed value. And that should be the answer that the back of the book gives you.
Yep, that's correct.
Of course it is. I'm the one who did the work. Now that you have this equation, you can answer part C, which is use the equation to predict the value of y when x is minus 2. Alright? So, x equals minus 2. That would mean that we have y equals 16 minus 2 squared. Minus 2 squared is positive 4, so it should be 16 minus 4, which is 12.
I got it right.
Hooray!
Also, sir, my question from before, you know how you said the r is a -1, so it's a perfect negative linear?
Correct.
So if the r was a decimal, would it what would it be?
If the r was... remember that your Pearson value can be anywhere from -1 to 1.
Yeah.
And there's a whole table that should definitely be in everybody's reference material for what those mean. There's blocks of about 0.25
Yep.
that can determine the strength of the relationship. So
What page is the table on, sir?
The table should be part of... I believe it is part of... Aha, here we go. Part of 3E. I'm just going to bring up...
3E.
There it is there.
Ah, okay.
Yeah. That one over on the far end there. Strong positive association, strong negative association. A perfect association would be 1 or -1.
Yep.
All right.
Got it.
So you're going to have different degrees of strength depending on what that R value is. Remember that R squared is your coefficient of determination.
Yeah.
Which we'll talk about in a later question. All right. So going back to the original question from 5B. The other question that was asked was about question 3. Slightly different numbers.
No, let's skip question 3 because it's pretty same thing.
It's pretty same? All right, fair enough
Yeah.
then. All right, I'll stop that recording.